The sum of first three terms in an AP is 21 and that of last three is 69. If the AP has 7 terms, what is the geometric mean of first three terms? Okay, so that's a simple question. First three terms, since there are 7 terms, what we can do is A minus 3D, A minus 2D. This way we can go up to the fourth term will be A, then the seventh term will be A plus 3D, right? So the sum of first three terms, so we are having the first three term is A minus 3D, A minus 2D and A minus D, right? So the sum will be 3A minus 6D and that is 21, and similarly 3A plus 6D is 69. So we can get the value of A, that is as 90 divided by 6, so that's 15. Okay, so this is 15, and by putting the value of A in any of these equations we can get the value of D. So 15 into 3, 45, 45 minus 21, 24, so D is equal to 4. So we can get the value of first three terms, so that is A minus 3D. So 15 minus 3 into 4, 12, so that's 3. Then A minus 2D, then A minus D, difference will be same definitely. And now we have to find out the geometric mean of these three terms. So it's 21 into 11, so it's 231 cube root. Okay, so that's simple. I hope you are clear. If A, B, C, D are four positive real numbers with A plus B plus C plus D is equal to 1, then the maximum value of AB plus BC plus CD plus DA can attain is. Okay, so see, if we rewrite this statement AB plus BC plus CD plus D, I can take B common from these two and D common from these two. So what I'll be getting, A plus C into B plus D, right? So I can factorize this into this. So precisely we have to find out the maximum value of this expression, right? Now we have A plus B plus C plus D. I consider this as one term. I'm sorry, A plus C, I just rewrite A plus C plus B plus D is equal to 1. I consider this as one term and this as one term. Okay, now we know AM is arithmetic mean of numbers is always greater than equal to their geometric mean, right? So arithmetic mean of A plus C and B plus D, what that will be? A plus C plus B plus D by 2, right? This is just one term, so hence I am writing it down as divided by 2 only, because one term plus one term, so 2 terms. So this will be the arithmetic mean of A plus C and B plus D. That should be greater than equal to their geometric mean. Now what is their geometric mean? A plus C into B plus D, square root of this. Okay, now we know the value of A plus C plus B plus D, that is 1. So that's 1 by 2 is greater than equal to A plus C and B plus D. Okay, now since we have to find out the value of A plus C into B plus D, we can remove the square root. So in that case it will be 1 by 4, right? So this expression will always be less than 1 by 4, right? Okay, the sequence A1, A2, A3 satisfy the relation AN plus 1 is AN plus AN minus 1 for n is greater than 1, given that A20 is this and A18 is this. What is A16? Okay, so precisely AN plus 1 is equal to AN plus AN minus 1. That means the next term is sum of the previous two terms, right? So I just can put up very simple example. Suppose first term is 1, second term is 2, then the third term will be sum of these two, fourth term will be sum of these two, then this, like this. Okay, so here we have been given the value of A20 and A18. So I put up n is the given values over here. So suppose n is 19, that means A20 is equal to A19 plus A18. Right, now A19 we don't know, so I just write down A18 plus A17 plus A18. Okay, now we have to find out the value of A16. So I have to eliminate 17 and I have to bring 16. Okay, so since A16 plus A17 will be A18, so A17 can be written as A18 minus A16, and 2 times we already have A18, so 3 times A18 minus A16 is equal to A20. That is the relation we have got. Okay, so A16 will be 3 times A18 minus A20, so 3 times 2584, I just multiply. And then I deduct 6765 from this. 12 minus 5, 7. So unit place is 7. So this option must be correct. Okay, difference is around 1000. So this option is correct, right? So this is how we can solve the sum. I hope you are clear. The sum of two numbers is 20 and their geometric mean is 20% lower than their arithmetic mean. Find the sum, find the ratio of the numbers. Okay, so let the number be A and B. So their arithmetic mean will be A plus B by 2 and their geometric mean will be root AB. Okay, now sum is 20, so A plus B is 20, so A plus B by 2, that is arithmetic mean, will be equal to 10. So geometric mean will be equal to, geometric mean is 20% lower, that means geometric mean is 80% of this, so geometric mean is 8. Now you can take more than one approach over here. Since arithmetic mean is 10 and sum has been given to us as 20, that means A plus B is equal to 20 and root AB is 8, that means AB is equal to 64. Now you can find out two numbers whose sum is 20 and product is 64. So that easily we can say 16 and 4, right? Their product is 64 and sum is 20, right? So now just look at the options. We should be having the option in 4:1 ratio or 1:4 ratio. So that's there over here. So I hope it's clear. For what values is 1 by x is less than x satisfied? That means x is greater than 1 by x. I'm sorry. Now in case of inequality, just always be careful, do not go for the cross multiplication. What you can do is x minus 1 by x is greater than 0. Now just take LCM. So you'll be getting x square minus 1 upon x is greater than 0. That means x minus 1, x plus 1 by x is greater than 0. Now you can go for the wavy curve method that I have already explained several times. So it's 0, it's 1 and it's minus 1. Okay, so since we want this value to be greater than 0, so that is between minus 1 to 0 and above 1. Okay, so x should be greater than 1, right? And x should be between minus 1 to 0. So this option. So this and this, both of them are correct, right? You can see the part above the line. So x is greater than 1 and x is between 0 to minus 1. Okay, so this option is correct. So just be careful, never ever go for the cross multiplication in case of inequality. Specifically where there is a variable in the denominator. In case if there is a constant in the denominator, then it really doesn't make difference if you go for the cross multiplication. But in case if there is a variable in denominator, then don't go for the cross multiplication. So generally too many students ask why can't we do this, so I just solve it for you. So in that case, what will happen if we go for the cross multiplication? It will be x square minus 1 is greater than 0. So x minus 1, x plus 1 is greater than 0. In this case, you are missing the x that was there in the denominator, right? You can compare this and this, right? So if you go for, I'm sorry, x square, so if you go for the cross multiplication, you will be getting this equation. If you take all the terms aside and take LCM, you will be getting this expression. So this 0, 1 and minus 1. So you'll be missing this portion over here. Okay, so in that case, you will end up getting the wrong answer. Okay. Let n is equal to 0 .xyz, xyz, xyz, and m is equal to 0 .ab, ab, ab. Okay, so both of them are non-terminating numbers, but definitely rational numbers because repeating digits are repeating. So precisely n is equal to 0 .xyz, xyz bar. So that is actually xyz by 999, and m is equal to ab bar, that means ab by 99. Okay, so which of the following is an integer? Okay, so since we don't know the value of xyz and ab, so we have to see n plus m we have been asked. So the number to be integer, that should be multiple of LCM of 999 and 99. Okay, so if we add them, so we are going to take the LCM in the next step. So that's 99 and 999. So we can take the LCM of these two. That should be there in the denominator. So to get an integer, whatever is there in the denominator, if we multiply that number to the fraction, then we'll be getting an integer. Okay, so precisely what we have to do, we have to find out the LCM of 99 and 999. So 99 is 3 into 3, 11, and this is 3 into 11, sorry, it's 3 into 3 into 37. Okay, precisely it is 111 into 9, so I just have to have one more 3. Okay, so LCM will be 37 into 11 into 3 times 3, so that's 27. Okay, so we should be getting a big number with we cannot get this very small number, that's very big. So 37 into what, precisely it is 37 into 297. So something around 300, 37 into 300 almost. So around 10,000, 11,000. So this will be the correct choice. Okay. So I hope this question is clear. Now see this problem. If x upon y plus z is equal to y upon x plus z is equal to z upon y plus x, and we have to find out the value of this expression. So since we wish to get x plus y plus z, what we can do, we can just take reciprocals of them. If these three expressions are equal, their reciprocal should also be equal. That means z plus y by x is equal to x plus z by y is equal to x plus y by z, right? Now if these three expressions are equal, if I add 1 in all the three, still they will be equal. Okay, now if I take LCM, what I'll be getting, x plus y plus z by x, right? Here it is x plus y plus z by y, and here it is x plus y plus z by z. So I can take x plus y plus z common from all the three terms. That means we will have 1 upon x is equal to 1 upon y is equal to 1 upon z. That means the reciprocals will also be equal. That means x is equal to y is equal to z, right? So you can take any value for x, y and z, and all of them should be equal. So precisely it is 1 upon 1 plus 1 plus 1, that's 3. So it's 1 by 3. Okay. What values of x will satisfy inequality this? Now that seems to be very interesting question, but very simple, definitely. See, in this case, b square minus 4ac is less than 0. That means the roots of this equation, x square minus 3x plus 208 is equal to 0. The roots of this equation are not real. Okay, so if the roots are not real, the value of this expression will always be greater than 0. Okay, it will never cut x-axis, never cut x-axis. Okay, so it really doesn't matter what is the value of x for this inequality to be greater than 0, right? Any value of x is there, may be there, the value of this inequality will always be greater than 0, or value of this expression will always be greater than 0. Okay, graph will be something like this. Okay, x is equal to 0, in that case y will be 208, so this is the point, but this parabola will never cut x-axis. That means y is never 0. So if y is never 0, the value of this expression will not equal to will never be 0. In that case, it is always positive. So if it is always positive, it really doesn't matter what value of x do you take. It can be any. Okay. So I hope this is clear. So the answer to this question is none of the above. For all values of x, this expression x square minus 3x plus 208 will be greater than 0. Once again, we have the problem where we have to find out the sum of the series to n terms. So whenever we have to find out the sum of n terms or m terms or whatever, you just take the comfortable values of n, right? N or m, whatever is the variable. So here suppose I take n is equal to 2, that means sum of 2 terms, so that should be 9, right? So when n is equal to 2, I should be getting the answer as 9, right? So but in this case you need to check more than one option, because say sometimes what happen, 2 of the options or maybe more than 2 of the options produce the same value. Okay, so let's see what happens. So suppose I put n is equal to 2, so that in that case it will be 4 minus 1, 3 minus 1 plus 2 plus 4. Sorry, 4 minus 1, so that's 3. 2 raised to 2, so 4 minus 1, so that's 3 plus 4, 7 and 2, 9. So it is producing 9. So if it produces 9, it cannot, because in that case this expression will be negative. So it's wrong. Over here expression is similar, but plus n minus n square. So if it is negative, it is positive, then also it cannot produce 9. So this is cancelled. In this case it will be 3 2 raised to 4 2 raised to 2 plus 1. So instead of 3 it will be 5. Okay, so further it cannot produce 9, right? 5 plus 4, 9 plus 2, 11, right? So this is the correct answer. So I hope this method is clear to you. Whenever you have to find out the sum of the series to n terms or m terms, just take some comfortable value of m, n, n. Do not go for one that will be quite general. You can end up making mistakes if you don't check all the options. So just go for at least 2. Okay. Find the value of this expression a minus b whole square by b minus c, c minus a, b minus c whole square. Okay, so to make it simple, what we can do, we can multiply here in the numerator and denominator by a minus b. So over here a minus b, here b minus c, and here c minus a. So we will be getting the same denominator in these cases. So we can take the LCM very simple, easily. Okay, so we'll be having a minus b whole cube plus b minus c whole cube plus c minus a whole cube by a minus b, b minus c, c minus a. Now this expression, suppose this is x, this is y and this is z. So x cube plus y cube plus z cube is equal to 3xyz if x plus y plus z is 0. So x plus y plus z, that is a minus b plus b minus c plus c minus a, that is actually 0. So that means x cube plus y cube plus z cube will be 3xyz. That means this expression will be equal to 3 times a minus b, b minus c, c minus a. Right. So in the numerator we are having 3 times a minus b, b minus c, c minus a, and in the denominator we are having a minus b, b minus c, c minus a. So that will be cancelled. So we will be left with 3 only. Okay. So that's pretty simple, and we are using this algebraic formula, that is a cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, a square plus b square plus c square minus ab minus bc minus ac. So in that case, if a plus b plus c is 0, this entire right side will be 0. So a cube plus b cube plus c cube will be 3abc. So the same funda I am using over here. Okay, so I hope that's clear. Now we try this question. 1 upon a square plus 1 upon b square is equal to 29 by 100, where a and b are positive. Find 2 by 3 plus a plus b by a minus b. Now 1 by a square plus 1 by b square. See, if we just look at this relationship carefully, this equation carefully, what we can do is we can easily find out the value of a and b. See what is happening over here. 29 by 100, we can write down it as 25 by 100 plus 4 by 100, right? So this is precisely, no need to write, but I'm just writing for you for your reference. 1 upon a square may be 25 by 100, and 1 upon a square may be 4 upon 100, and 1 upon b square may be this or this, right? So we cannot get the unique values of a and b. Right. So, we know that both of them are positive. So a may be 5 by 10 and b may be 2 by 10, or a may be 2 by 10, b may be 5 by 10. Okay, the square root of these two, right? Since we just have to take the positive values. But over here in the denominator, see, in the numerator it really doesn't make difference because both the variables are being added. But in the denominator, a minus b is there. Right, that means we have to find out the difference of a and b. Now this difference may be positive, may be negative, right? If it is 5 by 10, if a is 2, see 1 upon a is 5 by 10, so a may be 2, and if 1 upon a is 2 by 10, then a may be 5. In that case, a will be 5. So a and b 2 or 5. So we cannot get a unique value of a minus b. Maybe a is 5, b is 2, maybe a is 2, b is 5, right? So in that case, a minus b can produce maybe positive, maybe negative value, right? So uniquely we cannot determine the answer of this question. So it is can't be determined. Okay, I hope you are clear. Solve the inequality x square minus 10x plus 21 is less than equal to 0. The problem is simple. First we do the factorization. X minus 7, x minus 3, and that is less than equal to 0. Just go for the wavy curve method. 3, 7, start from here, this. Okay. So since we want the values to be the expression to be less than equal to 0, so that will be between 3 to 7. So x should be greater than 3 and less than 7, equal to, in fact. Okay, so that's pretty simple. Wavy curve method I have explained in so many videos, so many classes, so you just can refer the sessions once again if you are not clear about it. Okay, I take the next one. If a is equal to minus 7, b is equal to 5, c is equal to 2, then the value of a cube plus b cube plus c cube minus 3abc. So we have already discussed this formula so many times. A cube plus b cube plus c cube minus 3abc is equal to a plus b plus c, a square plus b square plus c square minus ab minus ac minus bc, right? So if a plus b plus c is equal to 0, this entire right hand side portion will be 0. In that case, a cube plus b cube plus c cube minus 3abc will be 0. That means a cube plus b cube plus c cube will be equal to 3abc, right? So in this case, we have to find out the value of this. Now we just check what is the value of a plus b plus c. So that is minus 7 plus 5 plus 2, and that is equal to 0. Right? So a cube plus b cube plus c cube minus 3abc will be equal to 0 because a plus b plus c is 0. Okay? So just an application of this formula. I hope you are clear. If x plus y is equal to 6, the maximum value of xy is. Now we can easily use the am is greater than equal to gm property over here, right? So am is greater than equal to gm of two numbers. That means x plus y by 2 will be greater than equal to root xy. The only thing is we should have been given over here that x and y, both of them are positive numbers, but since options are there is none of these, so I am assuming that x and y, both of them are positive numbers. Okay. So x plus y by 2 is greater than equal to root xy, right? So x plus y by 2 is what? It's 6 over here. 6 by 2, it's 3. So that's this. That means xy will be less than equal to 9. So the maximum value that xy can achieve is 9 only. Okay? So that is simple AMGM concept.